Got a question. Which days are the strongest? Saturdays and Sundays. The rest are weekdays. Doo Boo, right? Anyway, what's going on, Algebra Bros? In this video, we're going to discuss the topic of domains of combined functions. A combined function is basically what you get when you take two functions, say f and g, add them, subtract them, multiply them, or divide them. So we're going to do that in this example, but we're going to take it a little bit further and figure out what the corresponding domain would be. And as you'll learn, we have to kind of take care with that. And it depends on the domains of the two functions that you're adding together to begin with. All right, so let's get started. In this example, what we want to do is add two functions, f and g. F of x is 1 over x minus 1, and g of x is 3 over x plus 4. So we'll do that first. We'll add them together, and then we'll find the corresponding domain. Let's go ahead and figure out what f plus g of x is going to look like. First of all, as a quick reminder, you can rewrite that notation as f of x plus g of x. What you want to do from there is bring in the expressions for each function, namely 1 over x plus 1 and 3 over x plus 4. Now you notice that we're really just adding two rational expressions, so we'll need a common denominator, as Arnold would say, in which case the common denominator is just going to be the product of each of these. So let's go ahead and rescale each rational expression. I'll start with the first one by multiplying the bottom by x plus 4, which requires multiplying the top by x plus 4. Similarly, we'll multiply top and bottom of the second fraction by x minus 1. Simplifying the numerators of each, we'll have x plus 4, the numerator of the first fraction. Denominator would be the product x minus 1 times x plus 4. And then with our second fraction, you'd want to distribute 3 into there, so 3x minus 3. And on bottom, again, the common denominator. Now that they each have the common denominator, we'll add the numerators together to get 4x plus 1, and we'll write that on top of just one copy of the common denominator. There's no additional things left to do, no simplification, etc. So this is what the combined function f plus g of x looks like. So this is the function we get if we were to add both f and g together, in which case we did. So that takes us to the second part where we're going to find the corresponding domain. And for that, I want to kind of cycle back up here to the verbiage at the top of the page, where it kind of gives us an idea or a strategy as to how we can do this. It says when you add, subtract, multiply, or divide two or more functions, the new domain, i.e. the domain of the combined function, is the intersection of the original domains. So basically, we have to take what's in common between the domains of f and g. Now, depending on the functions that you're working with and the operation, there might be some additional values to exclude. Namely, you must also exclude any additional values that either cause division by 0, or negative numbers inside even radicals. Alright, so with all that said, here's how I like to figure out what's in common between both the domains of f and g to get our official domain for this answer. I like to do some drawing. First thing I'm going to draw is a number line, which will represent the domain for the function f. And here's some neat notation you can use. I'm going to label this number line as capital D sub f, which is my notation to indicate the domain of the function f. So let's take a look at the function f that was given in the example. It is 1 over x minus 1. There's only one value of x that you should exclude from this domain, and that's positive 1. So on this number line, I'll draw a tick mark and label it positive 1. Since that's the only x value you can't use in the domain of the function f, everything else is fair game. So basically anything to the left of 1 you can use in f, and then anything to the right of 1 on the number line you can also use in f. Another thing that I'd like to draw here is a number line representing the domain for, you guessed it, the function g. Now if we look at our function g in the example, there's only one value of x that we should exclude from it, and this time it would be -4. So on the number line for d sub g, I'll put a tick mark a little bit further to the left of 1 on the top number line and mark it -4. So just focusing on the function g, we can use anything that's less than -4 for the domain of it, and we can use anything that's greater than 4 as part of the domain for the function g. So just to recap, for the domain of the function f, x cannot equal 1. That creates division by 0. And so here's a visual of that fact. For the function g, x cannot equal -4. And we have the corresponding visual for that. The last thing I'd like to draw up here is a number line representing the domain of the combined function f plus g. And the notation I'll use for that is capital D subscript f plus g. Oops, there it is. All right, so as it says at the top here, the new domain is the intersection of the original domains. So basically, we're tasked to figure out what is in common from a shaded perspective between the number lines for d sub f and d sub g. Well, it's basically going to be everything that doesn't include 1 and -4 at the same time. Let me phrase that a different way. The only thing that's not in common between the number lines for d sub f and d sub g are the numbers that we're skipping. Everything else is fair game. So what's not in common is the 1 and the -4, meaning that every number other than 1 and -4 is being shaded in both number lines. So with that said, the stuff that's in common between both f and g basically excludes -4 and +1. So on this number line, I'm going to put a tick mark for -4, a tick mark for +1, and every other part of the number line here will actually represent domain values for this combined function. So what that means is we should shade to the left of -4, we should shade between -4 and +1, and then we should shade to the right of +1. How could we maybe determine that fact? Maybe based at looking at our combined function f plus g. Well, you'll notice in the denominator we have both the factors x minus 1 and x plus 4. So if we just look at the combined function at face value, it also tells the story that we should not use -4 and we should not use +1. I'll summarize that above this number line. X cannot equal -4 and x cannot equal +1. And you'll notice that that's the combination of both domain restrictions from the domain of f and the domain of g. All right, so with all that said, let's go ahead and draft up our interval notation representing our official answer for the domain. Parentheses -∞, comma, -4. Okay, that represents the stuff to the left of -4 on our final number line. We'll union that with parentheses -4, comma 1. Okay, that represents the middle shaded part. And then we'll union that with parentheses 1, comma infinity. And that represents the shaded stuff to the right of +1. And that would be our official domain. All right, gang. Thanks for sticking through with me on this video. Of course, if you have any questions about anything that I went over in it, feel free to reach out to me. Otherwise, I will see you next time. Thanks for watching.